In the previous lectures, we discussed about overlapping subproblems and memoization. And we told that there is a third portion of dynamic programming which is called optimal substructure. And in this lecture, we will actually talk about that. The optimal substructure is a very simple thing actually. So by formal definition, it can be phrased as, let's say you have a problem and you want the optimized answer of that problem. If the answer of that optimized problem can be derived from some of the subproblems of that problem, then it is called an optimal substructure. Well, the formal definition may not make sense that much, so we will give some examples to make you understand more what is it. Let's start with the simple Fibonacci number again. So what is the question when you are trying to find a Fibonacci number? The question is, you are given a number n and you want to find out the nth Fibonacci number. So your question is basically, what is the nth Fibonacci number? And this n can be anything like 1, 2, 3, 4 till 100 and beyond. Now we know that the nth Fibonacci number is the summation of the n minus 1th Fibonacci number and the n minus 2th Fibonacci number. Now if you think about it, how can you get the n minus 1th Fibonacci number? Don't you have to ask the same question again, that what is the n minus 1th Fibonacci number? As you see, the question is a little bit different, but the structure is the same. So the nth Fibonacci number is actually dependent on the same question but with different parameters, that is n minus 1 and n minus 2. You also can think of it like a recursion, like you are asking the same questions but with different parameters. Let's give another example. Let's say we have a city which is called Dhaka, where we live in, and from Dhaka you want to go to Chittagong. And right now I will be making some examples, not actual facts, so just bear with me. Let's say we have to go through Kumilla to go from Dhaka to Chittagong. And let's say from Kumilla to Chittagong, for the shortest path we have to go through, right now nothing is coming to my mind actually, so I will just make a city which is named City X. So let's say that from Dhaka to Chittagong, the shortest path contains both Kumilla and City X. Then you can certainly say that from the shortest path from Kumilla to Chittagong, City X will be in between. Because otherwise, if there was another way of going from Kumilla to Chittagong in a shorter way, then that would have been the shortest path from Dhaka to Chittagong, right? So you see that if you ask the question, what is the shortest path from Kumilla to Chittagong, you will come up with this sequence, from Kumilla to City X and then from City X to Chittagong. And when you ask the same question about Dhaka, what is the shortest way to go from Dhaka to Chittagong, the answer you have is Dhaka to Kumilla and from Kumilla to City X and from City X to Chittagong, which is partially the answer of the question that what is the shortest path from Kumilla to Chittagong. So you can see the answer of the shortest path from Kumilla to Chittagong is actually in the answer from the shortest path Dhaka to Chittagong, and it can be called a nested solution. So the optimal answer for the shortest path from Dhaka to Chittagong actually contains the optimal shortest path from Kumilla to Chittagong, and that is what is called the optimal substructure. That if any problem can be optimized through another version of the same problem, which is a sub-problem of the main problem, then it is called an optimal substructure. And also there can be many other options. Let's say from Dhaka we can also go to let's say Gaibandha, and we can go to Norshindi, but the shortest path from Dhaka to Chittagong actually goes through Kumilla, and that is the optimal answer we are looking for. So there can be multiple ways of going from Norshindi to Chittagong and also from Gaibandha to Chittagong, but the optimal answer for Dhaka will go through the optimal answer for Kumilla, and that's what we call optimal substructure. That an optimal answer is dependent on one of the subproblems' optimal answer. And in dynamic programming, we'll also see that the problems are solved using this optimal substructure. When we will see an example, we will get to know it better.